Hello guys, welcome to my channel. Today I'm starting with the new series on the fundamentals of system design. I will cover all the concepts which you should know for designing a system, and then we will move to examples where we will use these fundamentals to design a system. So today we will talk about a very important concept in system designing, which is scalability. Scalability describes your system ability to adapt to change and demand. It refers to the ability to increase or decrease IT resources such as virtual machines, databases, and networks as needed to meet the changing needs. If you are running a website, web service, or an application, its success directly depends on the amount of network traffic it receives. It is common to underestimate just how much traffic your system will receive, especially in the early stages. This could result in a crashed server or a decline in your service quality. Good scalability protects you from future downtime and ensures the quality of your service. Let me give you an example. Let's say you have launched a new service that converts Word to PDF, and you have one server with 32 GB RAM and 100 GB of hard disk to process the requests. Let's say initially in 1 month you were getting 1000 requests per second and your system was able to handle those requests efficiently. Now your business has become popular, and in the third month you start to get 10,000 requests per second. That also your system is able to handle, but at fifth month, let's say you're getting 1 lakh requests per second, but now your system is processing it very slow, and your customers are also complaining about the same, that it is taking too much time for conversion. So now you are in a situation where you need to scale your system to keep up with the pace of your business. But what options do you have when it comes to implementing scaling and ensuring your business scalability? There are two options. One is to increase the size of the system. Second is to increase the number of systems. Let's apply both these solutions in our use case and analyze. So by increasing the size of the system means that you have to buy a bigger system having more RAM and hard disk. Let's say you bought 128 GB of RAM and 500 GB of hard disk, and now your system is working fine. But after some time, let's say your product has become so popular that you're getting 1 million requests per second. Again, you can increase your system capacity. Say you have got 256 GB of RAM this time. This process of increasing the size of the machine or the server is called vertical scaling or scaling up. But there is a limit to increase the system capacity. You cannot go beyond a certain point. Now let's look at our another option. Instead of increasing the capacity of the same machine, we try to add more machines to handle the traffic. So now you can add a new machine each time you feel the need to increase the system capacity. This process of increasing the number of machines is called horizontal scaling or scaling out. So now we have successfully solved our problem of scalability when traffic is increasing. But now you have observed that you are getting 1 million requests per second only during a certain period of time in the day. Let's say 2 to 3 p.m. only you are getting the 1 million requests per second, but rest of the day the request count is just 10,000 requests per second. So you realize that you have spent a lot of amount in increasing the machines, but that is getting used only one specific hour in a day, and other times it is just an overkill to have those machines. Also, it takes more time to increase the number of machines and configure it. So now what is the solution to this problem? This happened because you are scaling your system on premise. But let's say if we use any one of the cloud service providers like AWS, Microsoft Azure, or Google Cloud Provider, then we could automate the process of scaling the resources. Also, with the cloud providers, you are charged only for the resources you have used. If the requests are increasing for 1 hour in a day, your cloud provider will increase the resources only at that time and charge you more for that time, and will scale down once peak hour has passed. This scaling concept not only applies to servers but can also be extended to any resources like bandwidth, databases, etc. So, while designing any system, one should keep scalability in mind and try to design systems such that while scaling, the performance of the system should be consistent. Also, it should be cost efficient. Now, let's just compare the horizontal and vertical scaling and decide which one to use and when. In case of vertical scaling, we deal with the single point of failure. since there is one single resource on which whole system is relying, and in case it fails, whole application can come down. While on the other hand, horizontal scaling makes system more resilient and fault tolerant. Since all your data and operations is divided among nodes, so even if one machine goes down, there is another machine present to handle its load. So there is a very slight chance that all the machines go down at the same time and cause system to become unavailable. Which brings us to our second point, that horizontal scaling also makes system highly available, whereas with vertical scaling, in case you decide to change something, you need to schedule a downtime when your service will not be available for the end users. Now, when a single node handles all the layers of your services, it will not have to synchronize and communicate with other machines to work. This may result in faster responses. But when there are multiple nodes, you need to set up a way for those nodes to communicate, which happens via network calls or messaging, which makes it slower than the interprocess communication, which happens in case of vertical scaling. This part I have covered in detail in my previous video in microservices about how different services communicate. You can check that out. Now, the fourth point is consistency. Let's think it in terms of databases as a resource. If there is one database, there is no issue with the data consistency. But when there are multiple databases, then you need to make sure that data between the different instances of database remain consistent. So to do this, we might have to apply lock on all the database instances while making a transaction, which is practically not possible. So how we deal with this situation is via eventual consistency, which I'll explain in third or fourth part of this series. Now, when there are multiple resources available, then you have to do some setup to transfer the load between them. Therefore, load balancing is required in case of horizontal scaling. I'll explain load balancing in detail in my next video, so please subscribe to my channel to get those notifications. But in case of vertical scaling, there is one resource, so it is easy to maintain and no additional logic for load balancing is required. Last but not the least, with vertical scaling, there is a limitation to how much you can upgrade a machine. Every machine has its threshold for RAM, storage, and processing power. But horizontal scaling requires you to do is to add additional machines to your current pool. It eliminates the need to analyze which system specification you need to upgrade, so scaling is easier in case of horizontal scaling. Now let's discuss which one to choose. So for that, let's consider some points. So first point is, consider your application footprint. When your business caters to a global audience, you need to deliver applications across geographical regions. To efficiently manage disasters and downtimes, choose horizontal scaling. Second point is balance cost and performance. When you scale up, you don't have the flexibility to choose optimal configuration for specific loads dynamically. The configuration power will limit the performance of the system. When you scale out, you can select the configuration to increase the performance and optimize the costs. However, it is essential to check if a single device can handle that load. In that case, adding more power instead of deploying multiple machines for the same purpose is beneficial. Third point is manage redundancy. When you scale up, you are logged with the single device, resulting in a single point of failure. When you scale out, it will offer built-in redundancy. However, you need to consider the cost of running a single device versus many. This brings us to our last point, which is best of both the worlds. In some instances, you don't have to stick to a particular scalable model. For example, if you use distributed storage system in the data center, you should be switching between the distributed systems and single disk mechanism. In such cases, you can try both vertical and horizontal scaling models so that you can easily switch between them. However, to make such a switch, your application should be designed with decoupled services so that some layers can be scaled up while others can be scaled out. So just remember one thing, while designing a system which meets the requirements and is feasible, there is always going to be a trade off between one thing over the other. We'll discuss all of this in detail in upcoming videos. For now, please subscribe to my channel and also please hit the thumbs up button if you like this video, and in case you have any doubts, leave a comment. I'll try to clarify.